Picture a sudden, brilliant burst of energy erupting in an endless, completely empty void, a true, instantaneous flash. To accurately record that event, pointing to its location falls short, and writing down the exact second it occurred isn't enough either. A physical event requires both. It exists as a single, indivisible point in what physicists call spacetime, a precise combination of where and when. In wave mechanics, researchers constantly need to trigger these kinds of perfectly isolated, microscopic sparks to study how ripples form. They simply call this a point impulse. But mathematically, you cannot just plug a simple number into a spacetime equation and spawn an impulse. You have to write an expression that actively filters out the infinite expanse of the surrounding universe. To capture a single event, we have to build a mathematical trap, one that collapses all of infinity down to a solitary, uncompromising here and now. This diagram shows a two-dimensional mathematical arena. The horizontal axis represents all of space, denoted by the Greek letter psi, and the vertical axis represents all of time, denoted by the Greek letter tau. To build our trap, we start with the spatial Dirac delta function, delta of psi minus x. This acts as a spatial filter, strictly commanding the math to keep only this position. Geometrically, this strips away the rest of the universe. But because it doesn't specify a time, that single location stretches forever up and down the time axis as an infinite line. Next, we introduce a temporal filter, delta of tau minus t. This command specifies only this moment, completely isolating a single frozen second. But without a spatial limit, that moment applies to everywhere in space simultaneously. We've defined here and now as independent, infinite lines. To trap our event, we need an operation that forces them to interact. So how do we combine these two independent filters? We multiply them together. This equation demonstrates how that works. Inside a double integral, multiplication acts as a strict logical AND. In the first step, integrating over tau forces time to stand still, locking in the temporal filter. Then, integrating over space forces the position to collapse. The spatial filter locks in. Multiplying the delta functions means keeping only the exact intersection of those two lines. The multiplication serves as a perfect mathematical sieve, eliminating every other coordinate until only that single specific location and time survives. By multiplying two completely separate one-dimensional equations, we forge a highly precise two-dimensional point source. The mechanism is wonderfully simple. One delta function picks the space, the other picks the time, and their product locks in the space-time event. Looking back at our diagram, watch what happens when we use this math in physics. This multiplied form is the absolute foundation for defining point impulsives, giving researchers the tool they need to find Green's function for wave equations. Without this specific multiplied product, physicists would have no mathematical way to cleanly isolate the microscopic spark that starts a wave. The mathematical universe is infinitely vast, but by layering simple single-variable filters on top of one another, we can slice directly through that infinity and locate the absolute here and now.